What up, athletes? Whoop, whoop. All right, here we got our warm-up. Since this is on video, take a minute. Feel free to do it. Pause me, because we're going to get started here in just a second. All right, I'm assuming you paused, took time for it. So let's look at this. Complete each function table. Well, let's do that. Okay. So it says to do 3 times W. 3 times 0 is 0. 3 times 0.5 is what? 1.5. 3 times 0.6 is 1.8, right? And so on and so forth. All right, you guys can get that. What's next? X and 2x minus 1. So what does that tell me to do? 2 times the x, subtract 1. 2 times 2 is 2, minus 1 is 1. 2 times 4 is 8, minus 1 is 7. 2 times 9 is 18, minus 1 is 17. And again, keep going that way. Last one's right here. See, it's 1 plus z divided by 4. So if z is 0, 1 plus 0 over 4, that's just 1, right? Because 0 fourths is 0. 1 plus 1 fourth, well, that'd be 1.25. That'd just be 1 1/4 or 1.25. Well, 4 divided by 4 is 1, and 1 plus 1 is 2. You just kind of keep going like that. Awesome. I'm going to erase all this, so pause me if you need to again. Write it all down, but make sure you're able to do it. The answer should totally look like that. Again, we're going to look at this for just a minute because we're going to move on. There we go. All right, y'all, sorry about that blip earlier. What did we have right here? We had that y equals x plus 5, I think. Yeah. It was 5, 7 plus 5. Yeah, perfect. And over here, what do we see is happening? Well, if this goes up by 2, this is going up by 6. Okay? And if this goes up by 9 minus 4 is 5, then this is going up. What's 28 minus 13? 15? Just want to make sure that the slopes are the same, right? So rise over run, right? It's so m equals change in y over change in x, which means our slope is equal to change in y was 6 over 2, which equals 3. Down here it was 15 over 5, which I know in my head is going to work out the same as 3. So we've got a slope of 3. Now we just need our start value. And our start value is, if we work backwards, I know if going 2 forward was 6, going 2 backwards is going to be minus 6 to 0, right? To 0. So 7 minus 6 is 1. So if that's my start value, I know my b equals 1. And I'm left with, this is y equals 3x plus 1. Oh. And last but not least, let's look at this bad boy right here. What's it going back by? Well, 6 to 18, and let's go ahead and scrub some of this work I got going on right here. Get it out of the way. I'm going to scrub this, so pause if you need to, but I'm scrubbing it. All right. All right, and let's see what we got right here. This is going to be, the change in x is what, 12? Dang. And the change in y is just 2. Not going to be a very big slope, I can tell you that, but we're going to confirm and make sure it's the same. Change in x here is 18, and the change over here is 3. Now we want to confirm that this slope is the same, okay? So I'm going to have 2 over 12 for our slope, which is just 1/6. And I think it's going to be the same, but let's see, 3 over 18, yeah. 3 goes in 3 once, goes in 18 6 times, that's 1/6. So we have a slope of 1/6. And that means every time I go up 6, I go up 1, right? So if I'm going to go back 6 to 0, I'm going to go down 1 to 0, which means my start value is 0. So this is just y equals 1/6 x. Boom. That's like kind of a meaty warm-up, right? So copy these down. I'm going to hit show answer just so you can see it's all good. There we go. 3x plus 1, x over 6, by the way, x over 6 is 1/6 x. That's a 1 next to the x, right? And x plus 5. Boom. Let's get rolling. We're going to bust through this lesson pretty quick. I'm up against the time limit of class about to start, so let's see if I can get her done. Okay, take a minute, write down these. It's funny, these are going to look very similar. You're just writing these definitions down. Inverse relations, two relations, one of which contains points of the form AB while the other contains points of the form BA. So they're in an inverse relation if basically they have the same points with just flipped numbers, right? An inverse function is two functions, one of which contains points of the form AB and the other contains points of the form BA. So this one, you can be in an inverse relation and not be a function, but if you're in a function and you have that inverse relation, you're an inverse function. So we're going to talk about that today. Good stuff. All right, pause if you need to. We're going. Again, all this, you're going to hear me say pause if you need to. It's because I'm moving on, and that's your cue to hit, pause. And I want you to write this down in your notes, which I will have some guided notes that you can print out or just take them on your own. What is an inverse relation? If one relation contains the elements A, B, then the inverse relation will contain the elements B, A. Symbols, this means AB approaches BA, right? It just changes to BA. So in other words, A and B are in inverse relations if A has -8, 12, and B has 12, -8 as a point. See how each one, -2, -5, we just switched their order, -5, -2. 0, 4 becomes 4, 0. 7, 16 becomes 16, 17. And here's what the graph looks like. It's kind of cool. So there's two lines here, right? The graph of the inverse, so just regular AB is the blue one. That's the regular one, right? That's our regular graph. But then the inverse graph is the inverse, and it reflects around the graph of y equals x. So this dotted line is y equals x. You'll notice they meet exactly on the line. That's where they cross. And they're just inverses. They're opposites about that line. So if you were to look at that line, you're going to see that it mirrors itself across it. Okay? So like this half would map directly onto this half, right? That's how the AB maps onto BA. Okay? For every point AB on the graph of the original relations, the graph of the inverse will include BA. Okay? All right. You can get this stuff written down as notes. You don't need this. You already wrote down the definition. Okay, and here we're just going to have a lot of practice. Determine the inverse of -8, 3. Okay. -8, 3 goes to 3, -8. 0, 14 goes to 14, 0. 11, 52 goes to 52, 11, right? And so on and so forth. 12, -6 goes to -6, 12. Let's check that. Oh, I didn't place it right. Yeah. Okay, we're just going through this again. What does -5, -9 go to? It goes to -9, -5. That's the inverse of it. -1, 3 goes to 3, -1. 2, -2 goes to -2, 2. 8, 19 goes to 19, 8. Boom. Told you a lot of this is going to be super quick. The only one that has any challenges when we actually start doing functions, and that's not that bad. Looking at a table, it's going to be the same process. Remember, this is an XY point. So 13, 11 would go to -11, 13, which we see is in the bottom two right here. 19, 8 would go to 8, 19. They both have that still. 44, 21 will go to 21, 44. That's this one. Now they're separate, and let's confirm the last one. 50, -17 would go to -17, 50. Boom. Right there. Look at that. I told you, this lesson's going to go pretty quick. It's not meant to be super challenging. We are going to have some graphing involved. Good stuff. Yeah, the graphing. What? Reset. I don't know why it keeps doing that. All right, so what do we have here? -4, 4 goes to 4, -4. -2, 3 goes to 3, -2, right? And you can pause this and fill it in before me and then check it, make sure you're good. But this should be 2, 0. And this should be 1, 2. Check it. Boosh, right there. Then we actually want to graph this bad boy. So I'm going to go to 4, -4, and 3, -2. So we've got 4, and then -4. And then we had another point, 3, -2. 3 is in the middle of 2 and 4. -2. Okay. What are other points? 3, -2. 2, 0, and 1, 2. So we've got 2, 0. Boom, right on the line there. And 1, 2. So 1, but up 2. Now check this out. It's going to make a line. I'm just going to connect it on 2 points right here, kind of the furthest away 2 points. Notice it hits everything. And what do we have right here? Notice, first of all, these are inverses of each other. They cross directly on that line of y equals x, which they're reflected around. And they cross right on that line. And then they're clearly mirror opposites of each other, right? That's what it is. Boosh. You can always check my answer. Look at that. You can't even tell. And this would be referred to, by the way, the notation of this is if this first line is f of x, the second line is f to the -1 of x. That's the inverse function. That's what that f to the -1 means. I actually like doing this stuff. It's kind of nice. This is just to show you that on graphs of inverse, you notice no matter where I move it, these are opposites of each other. Opposites, move again, they're opposites until this one point right here where they're going to equal each other. It's hard to get to exactly, I passed it. There we go, look at that, boom. Just to that point of y equals x, okay? So if we show that point, look, it's that point right there of y equals x. And that's y equals x, so it's like 1, 1, 2, 2, 3, 3. Awesome. Here's where you got to do a little bit of math to find the inverse function. And you're going to write these steps down. So I'm going to have you pause it, write them down. I'm just going to talk through it and then move on. It says replace f of x with y. Remember, y and f of x are the same thing. Interchange y and x in the equation. I'll explain that. And then solve the equation for y. Replace y with f to the -1 of x in the new equation. So let's get into this. All right, so we are going to solve for the inverse of f of x equals 1/4 x minus 1. Use decimals if necessary. We will if we need to, but we're not going to start off with that now. Okay, so what does step 1 tell us? It says to replace f of x with y. So we write down y equals 1/4 x minus 1. Step 2 says, hey, let's replace the x and the y. So I'm going to get x equals 1/4 y minus 1. And then step 3 says solve for y. So I'm actually going to take this and I'm going to multiply everything by 4 because I want to get rid of that denominator of 4. I want to get rid of the fractions. So I'm going to distribute this, right? So I'm going to have times 4. Then I'm going to have over here times 4. Okay, so what do I end up with? I end up with, I'm just going to write up over here, 4x equals y minus 1. And then y is already positive, so I might as well just add 1 to both sides, right? And I get that 4x plus 1. Wait. That should be a 4. Does everybody see what I did? I got to distribute it. It should be minus 4 right here. So then I'm going to do plus 4. Almost did that. I don't know why I keep forgetting to distribute that. So that'd be 4x plus 4 equals y. There we go. Now we're cooking with peanut oil. And because I want to have it as y equals mx plus b, I'm just going to switch sides. Y equals 4x plus 4. And then what does step 4 tell us to do? It says replace the y with f to the -1 of x, or the inverse f of x equals 4x plus 4. Boom. Go ahead and make sure you pause this if you need to. Write that down. We're going to go down here. We're actually going to graph it, so I've got to disappear this. That's 4x plus 4. So I'm going to have 4x plus 4. Check answer. Oh, right there. 4x plus 4. Now, they've already graphed f of x. They've already graphed that 1/4 x minus 1. We see it. It crosses through minus 1, and it's up 1 over 4, right? Okay. But we want to graph 4x plus 4. That's what we solve for the inverse and make sure it's the inverse. So we start off at 4, right? And I know the slope's 4, so normally I'd go up 4 and over 1, but since I don't have an 8 up here, I'm going to go backwards, actually. Go down 4 and back 1. I might as well do it twice. Go down to negative 4 and back 1 to 2. Perfect. And then I'm just going to draw that line. I'm going to connect it to the furthest away points. We got right here, right here. Here's what you notice. They also already graphed that line, y equals x, which we're told these inverses should meet at. And look, they meet right there exactly. And they look like mere copies of each other reflected across this line. Boom. All right, let's do this one more time. Now, if you're using the printed copy of notes, just so you know, I changed the number a little bit to make it graphable on a smaller graph, not quite so big on the Y, but this is a little different. That's the only thing that's different from those printed notes. All right, so here we go. Negative 2, f of x equals negative 2x plus 18. Again, step 1 tells us to replace that with y equals negative 2x plus 18. Then we're going to replace or switch, interchange the x and the y. X equals negative 2y plus 18. Awesome. Solve for y is step 3. So this is negative, so I'm going to go ahead and add 2y to both sides. Add 2y, and I might as well subtract x because I want to get it out of here. So minus x. No, I can't combine those, but I'm going to put it there. So I end up with 2y, that's gone, equals, that's gone, negative x. Okay, so minus x, and then don't forget the plus 18. Boom. So what am I going to do to solve for this? Well, I just need to get y by itself, so I'm going to divide everything by 2. Divide by 2, divide by 2, and I get y equals, that's negative 1/2 x plus 9. Now I will say this, only because I've tried it before and I found out the hard way. I forgot, it says use decimals if necessary. Because it's negative 1/2, we're going to say negative 0.5. So this is going to be y equals negative 0.5 x plus 9 before we enter it in to right here, or before you enter it into your, unless it gives you an actual math editor. If it's just giving you a little fill-in box like this, you probably want to use decimals if it says to use decimals. All right, and then what does the last step say? It says replace with f to the negative 1 of x, f to the negative 1 of x. So we know the inverse function of x is negative 0.5 x plus 9. Awesome. Good stuff. Let's put that in. I'm going to erase this. Pause if you need to. Peace. 5x plus 9, negative 0.5 x plus 9. Let's check it. Look at that. And let's graph it. Again, they already have f of x graphed, but let's try it. So it's starting out at 9. We know that. That's the start value. And it says negative 0.5x, which was negative 1/2, which if you think about that, that's really down 1 over 2, right? It's easier to graph with fractions. That's why I hate putting in decimals for graphs, but it is negative 1/2. We knew that. So we can do a few of those lines. It's down 1 over 2. I'm just going to do a few points because why not? Down 1 over 2. Look at that. They're going to meet right there. All right. It's a little off. Oh, must have attached that line. So what do I do now? Let's go ahead and do one more. Down 1 over 2. Boom. So let's do this line. Start right here. And look at that. This line kind of makes it look like a little dragonfly, but it's clearly a reflection of the original line. and they cross at exactly y equals x, which is what they're supposed to do. That's it. Awesome. Again, if you're doing this on paper, you'll notice the number's a little different, but the process is the same. You guys are amazing. So without further ado, peace out.